Hello and welcome back. We're going to continue our discussion about how we saw area and volumes on the AP. Now, of course, we're looking at the AB ones, but the same questions appear on the BC as well. This is typically AB, BC problems. There's only one other topic that they would only put on here, and that is arc length, which we're going to talk about in another video. All right, so let's take a look here. This is from the 2012. So 2012, we have this interesting little graph right here of region R. It is made up by the natural log of x and y equals 5 minus x. Of course, we should be able to recognize that this part right here is our natural log of x, and over here we have the function 5 minus x. So, and what we're asked to do is, we're looking at this region right here. Now, the interesting part is, if we take a look here, we want to know where these meet, so we have to find the intersection. Now the reason we have to find that is because if I'm looking to find the area, which they're asking me to, I am going to have to split into two different integrals. So we have to split this. So let's go ahead and find the intersection. Now this is a calculator question. We can tell this is question number 2. Question number 1 and 2 are always calculator questions. So I want to find out where they meet, so I take my calculator of mathematics. I'm going to clear up my memory here, clear everything out. And I go to here. Make sure you're always in radian mode. Of course, my home screen was in degree, but we're still in radian in the graph. I'm going to graph natural log of x, and then I'm going to graph y equals 5 minus x. Remember, to find the intersection, I want to find out where does the natural log of x equal 5 minus x. So I'm going to graph them and find out. That's probably the easiest way to do it. Tab. Now again, I'm using the cast, but if you have the CX, works just as well. Any calculator, graphing calculator will work, and if you're in my class right now, you have the online calculator, which works the same way. We get 5 minus x, graph that, press enter, and I'm going to look for where they meet. Menu, analyze graph, and I'm looking for that intersection. So let's see here, lower bound. And all I have to do is scroll over here to where they meet. And I'm going to go here. I can see the point. Now, it's kind of hard to see, so what I'm going to do is I'm going to get rid of this stuff. I'm going to get rid of the, whoop, not that, not you, you. Delete. There we go. Oh, no, let me see here. Delete. So let me see. Where's this point at again? All right, well, let me get me that. I'll probably have to find it again. So let me go and find that again. Sorry, all that stuff in there was kind of messing me up, so I'm going to find the intersection again, and it doesn't take long. There we go. And we get x equals 3.69. Now, we do want to go further, so an interesting skill somebody taught me. Hover your hand over the 3.69 and just hit the plus sign, and it goes a little bit further. So we know they meet at x equals 3.693. And I'm going to go with the 4 because I'm crazy that way right there. There we go. That's where they meet. Now, later on, we're going to talk about something called the shell method. That's really cool. So, but we're not going to worry about that today. All right. So for part A, we want to we want to find the area of the region R now. So now we can go ahead and start. We're going to do two rectangles of mathematics. One for the natural log part. Remember, we always measure area to the x-axis. And we're going to do one for the 5 minus x part. So let's go and do part A now. For part A, if I look at the first rectangle of mathematics, the skinny part's dx, because we are vertical here. We're in terms of x, so we're going to be vertical. And the height is going to be the natural log of x minus 0, so it's just natural log of x. And if I look at the other one, it is going to be dx thick, again, because that's the skinny parts, and we're in terms of x, so the skinny part's dx. And this is going to become 5 minus x minus 0. Remember, top minus bottom, and that's 5 minus x. All right, so our next part now, we're going to find the area. We're going to write this as two integrals right here. And that's going to become, the first one, just the natural log of x, dx, and I'm going to evaluate that from 1 to where they meet. 1 to 3.693 plus, and the second one, which is 5 minus x dx, and it starts at 3.693, and it's at 5 minus x, we know that just goes to 5. And I can type this in my calculator, which I will. Let's go and type that in our calculator. So let me go back to my home screen, homie, and type this in. I just typed in exactly as it looks, menu, 4. I'm going to choose 3, but if you can see x, it's going to be 2, I think. We can go from 1 to 3.693 natural log of x. Don't forget your dx. And I'm going to go plus. I'm going to add the other one. Just going to add it right there with it. Menu. Whoops, hello. Hit the wrong button. Go back. Menu. 3.693 all the way to 5. And we're going to type in 5 minus x. And again, don't forget your dx. And I just press enter. And we get 2.986. And there is our area right there. Now there's another way we can do this. If we have time in the video at the end, I'll show you another way we can find the area. Alright, so let's take a look at part B right now. So for part B it says the region R is the base of a solid. For the solid, each cross section is perpendicular to the x-axis. So we are perpendicular to the x-axis, so we are in terms of x. Right here. Write, but do not evaluate, my favorite phrase, an integral expression involving one or more integrals that gives the volume of the solid. Okay, now, I forgot to say this. Our cross section is a square. So the same thing again. So this is our cross section question. We're going to have two squares, one for the natural log, one for the 5 minus x. So I'm just going to go ahead and do that. Now, once we have the rectangles of mathematics, the squares are pretty easy. There's my base. Remember, this base right here is the bottom of there. So that's just going to be natural log of x dx, and this has a height of natural log of x. So the area here would be the natural log of x squared, because it's a square, right? The area of a square is s squared. Our next one, the base is going to be the 5 minus x, so that's going to be the bottom down here. Dx, and this area would be 5 minus, 5 minus x squared. Now, to get the volume, remember, for cross sections, volume is area of the base times the height. The height there, remember, is dx. That's our secret for it, right? So I'm going to go ahead and find the volume of both of those. The first one would be, well, to find the volume, the area of the base here, remember, are squares. So that's just s squared. So it's going to be our natural log of x squared. That's going to give me the area, but now I've got to multiply by that dx to get the volume. Our second one, 5 minus x squared. Again, that's going to give me the area of my face. Multiply by the dx to get the volume. And now we have to find our domains. Well, the domains are going to be the exact same up here. 1 to 3.693, and then from 3.693 to 5. And that would be your volume. Right here. So both of these questions are worth 3 points. You get 3 points here, 3 points here. Up here they wanted you to solve it. Up here they didn't say solve it, they just said leave it alone. Alright. The last part. It says the horizontal line y equals k divides R into two equal area. Write, but do not solve an equation involving one or more integrals whose solution gives the value of k. Now this one's a little bit trickier. So what they're saying here is that if I'm going to redraw this, let me go ahead and redraw this one right here. If I redraw it, let's go ahead and take a look at this one again. There's our natural log. There's this. Alright, so we know that that's 1, and this is 5. We know this is x equals 3.693. But what they're saying is that there's a line, y equals k, that will split the area in two. Now this one makes it a little bit tougher for us. Okay? So what they're saying is that here is y equals k. If I draw a line here, y equals k, that is saying the area up top is equal to the area below. So the equation we're looking to set here is area 1 equals area 2. Now this is not the only way to solve this one, but I think it's most consistent. But what I want you to notice is that this is horizontal now. So y equals k is horizontal. Now we talked about this before, Therefore, we need to be in terms of y. So let's go ahead and solve for both our equations in terms of y. The first equation was y equals natural log of x. That is just going to say, if I solve that for y, we're just going to get e to the y equals x. The other equation is y equals 5 minus x. Well, that's easy. That's just going to be x equals 5 minus y. So there they all are. Now we also need to find the point. Well, we know that this is x equals 3.693. What's the y value? So I got to go back over here, go back to my graph, and I can take a look at there, and it's 1.31. So the y value here is 1.31. You can look at that from your graph. All right. So once we have all that, so now we can kind of set this. So if I draw my rectangle of mathematics for area 1 and area 2, there's my rectangle of mathematics. It's going to be horizontal. The skinny part now is going to be dy. Right there. So we're going to go right minus left. I don't have to do 2 here because a1 and a2 is still going to be right minus left. The functions never change. So you don't have to do 2 separate integrals, 2 separate rectangles in this case. So you only do the one for both of them. And the right is going to be the equation 5 minus y minus e to the y. So the areas for both a1 and a2, so a1 is going to be from y equals k, or area 1, I guess I should, let me start over here, sorry about that. So to get the area, I'm going to go a1 equals a2. So I take a look, well, where does a1 start? Well, a1, my top one, starts at k, ends at the y value 1.31. To get that area, it's going to be, what was our area? Oh, this rectangle. 5 minus y minus e to the y times dy. And that's going to equal area 2. Well, where does area 2 start? 0 and goes up to y equals k. And the same equation to get the area, 5 minus y minus e to the y dy. And that's all you have to put there. Okay? Now, it's not the only way to do this one. There's another way you can do it. In part A, we got the area. You could say, like, A2 equals half the area. So how would I find A2? Well, that would be from 0 to k. Are you okay with that? 5 minus y minus e to the y dy equals 1/2. Well, from part A, we said the area was 2.986. 2.986. And that's another way we can solve it. And there's many other ways you can actually take a look and solve this equation right here. But what you want to do is you want to look at the graph. Anyways, I hope you enjoyed the video. I will see you later. You will have a question like this on your tests and quizzes. So I'll see you then. Bye-bye.